All right, let's take a look at number 1 together. Water is being pumped out of a cylindrical water cooler with a radius of 8 inches at a rate of 4 cubic inches per second. What rate is the height changing when the height is 12 inches? So let's kind of figure out all the stuff we've got there. We're talking about a cylindrical tank. So we've got a cylinder. We've got our radius. Key components to this measurements are going to be our radius and the height. Well, water's being pumped out of this cooler with a radius of 8 inches, so R equals 8, at a rate of 4 cubic inches per second. So we know this is going to be one of the rates, tells us right away, 4 cubic inches per second. And remember, when we see those cubic units per time, we know that's going to be the rate of the change of the volume with respect to time. Since it's getting pumped out of this water cooler, that means the water level is lowering. It's getting smaller. The volume in here is getting smaller, so this is going to be a negative value. Be careful with that. Always pay attention to the rates. Figure out if it's positive or negative. If it's increasing, it's positive. Decreasing, it's negative. What rate is the height changing? So we're trying to figure out dH dt. And we're doing this when the height is 12 inches. So it tells us this radius is 8. This right here, we've got r, dv dt, dH dt, we've got h. There's no dr dt, but if you think about it, is this radius ever changing? Right? Doesn't matter where the water level is, even if it's right here. The radius is going to be the same no matter what level the water is. So the radius is constant. We don't need a dr dt when something's constant. Our formula for volume, since we're talking about volume here, is the volume of a cylinder is pi r squared times height. So this may look kind of like the cone one from a first glance. We've got r and h. We don't know what dr dt is, but we kind of talked about this. Dr dt is actually 0. That's different here because the radius is never changing. In the cone problems, depending on the height, the radius is going to be different, so that has a rate of change. In this case, we can just go ahead and put 8 in for r. Since r always equals 8, it's constant, it doesn't change, we can go ahead and substitute that in here for the radius. Only because it's constant. If it were something that changed, depending on the other variables, then we couldn't do this. So we can write this as v equals 8 squared, so 64 pi, times the height. Now we can go ahead and look at the derivative of this. dv dt equals 64 pi times derivative of h is just dH dt. So we can substitute the values in that we have. dv dt we know is negative 4, and we're trying to find dH dt. So all we have to do is divide. dH dt equals negative 4 over 64 pi. And that is approximately negative 0.02 inches per second.